See, inductance is a measure of the ability of a device to store energy in the form of moving charge. Yeah, it's not comfortable, yaar. It's too cool.
क्या हुआ?
Somebody please decrease the speed of the fan, yaar.
Okay, I will do it. No increase, yaar. It's too hot. Do you know how does it speed up and speed down?
You don't know the concept behind it?
No.
Come, I'll tell you.
Okay.
Come.
Have you ever come across using a conventional fan voltage regulator to control the speed? Such type of regulator is called resistance regulator, which works on the principle of rheostat or resistance potential divider arrangement. Frequency of supply. Fan speed is directly proportional to frequency, but it is not practical, as the frequency of our own supply is fixed, 50 or 60 Hz. It is used rarely in industries where variable frequency supply systems are available. Number of poles inside motor. Think of it as the number of electromagnets inside the motor if you are unfamiliar with the term poles. Number of poles can be changed by changing the wind connections, which is also not practical for our domestic fan voltage control. This is the most popular method of speed control of induction motor driven fans. As the name suggests, it controls the voltage appearing across the fan terminal. Theoretically, fan torque is proportional to square of voltage applied. Resistive control. These are the regulators used back in old days. They are bulky and heats up at lower speed. Here are variable resistors connected in series with the fan. At full speed the resistance is 0. To decrease speed we increase the resistance by turning the knob. This will cause some problem voltage drop across the resistor. So the fan terminal will receive a reduced voltage. The fan will rotate at lower speed. The drawback is the power dissipation in the resistor, that is, to get reduced speed we are wasting some power into a resistor, which causes heating and energy wastage. Due to this, fan operating at full speed and lower speed will be consuming almost same power. There will be heat sinks and opening on top to dissipate heat from resistor coils, which make the design bulky.
Capacitive control. It is becoming popular nowadays. It is very similar to resistive control but less bulky and energy efficient. A variable capacitance in series is used in this regulator. As we turn the knob, the capacitance increases and it reduces the voltage available to the fan. The interesting point is that there is nearly no power loss in this method. The losses incurred are due to resistive losses inside the capacitor, which is almost negligible. There is no heating problem and the capacitor improves the power factor of the circuit. They are less bulkier than resistive controllers.
Now this is how the circuit of a conventional resistive fan regulator looks like. This is the knob which can be rotated so as to regulate the speed of the fan. When it's at 0.0, the speed is minimum, and at 0.5, the fan is at its maximum speed. Now getting into the circuit, we find that when the knob points at 0, the circuit completes via this path. That is, all the resistances which you can see here come into play, and thus very negligible amount of current flows through the circuit, which is not suffice to rotate the motor of the fan. Now when the knob is at 0.1, these 4 resistances come into play and the circuit completes via this path. Similarly, for second, third and fourth point, the resistance coming into play decreases and thus increasing the fan speed. Now at 0.5, what happens is the path through which the circuit completes consists of no resistance, as you can see here, and hence the fan rotates at its maximum speed. So friends, this was our project on fan regulator. I am Shivam, Atal,
Dhruv Kawat, Gaurav Chaudhary,
Vishnu, Bharat.